Hey, Bobby here with Coder Foundry. And last week I was in Dallas, Texas at the Commit Your Code conference, and I gave a talk on minimal APIs. And just in case you missed that conference, you couldn't attend in person or virtually, I thought I'd take the time here on YouTube to talk to you about minimal APIs. And minimal APIs at scale, and minimal doesn't mean small, it means flexible. And when we talk about minimal APIs, it has a few problems. And one of those problems is the problem of perception. And what people think minimal APIs look like is this. Over here is our program CS, and we've got some business logic, a record, and maybe a variable. And all of our endpoints are stuffed inside of one file, the program CS. And a lot of seasoned .NET developers say, you know what, this isn't ready for prime time. And so that's why you'll see the recommendation for minimal APIs is it's great for demos, but it's not for production. And that's because they look at code like this, and can you imagine a team of 20 or 40 developers working on a project that has 1,000 endpoints trying to code inside of one file? It'd make it hard to test, hard to scale, and hard to work on, hard to maintain. Now imagine you go to a job interview and they ask you to rewrite maybe a function or a method from Java and port it to C# because that's the job that you're getting ready to interview for. But they mistakenly gave you the entire code base, and over the weekend you wrote their entire code base in C#. It worked flawlessly and it worked perfectly, but you showed up with chili stains on your shirt during the interview, and they ask you to, hey, can you list out 5 prime numbers? And you list out 5, but you find a new one during the interview. When it gets down to say, hey, do you think I can work here? They're probably going to say, man, we really like your work. We're really impressed with what you did, but we're going to go in another direction because we just can't get past that chili on your shirt. And those first perceptions absolutely matter. And minimal, the name, is not equal to lesser, and that's what it sounds like. They could have named this anything they wanted, but they called it minimal API, and I think they had a good reason for that, but it sounds limited. I was in a store several years ago for Christmas, and there was someone trying to buy an Xbox for their son for Christmas, and they were choosing between a used Xbox 360 and an Xbox One, and they didn't know the difference. And I heard the dad remark, hey, 360 sounds like it's better than One, so let's get the 360. And I kind of pushed my way in line and said, hey, you know what? I'm just going to help you out here. The One is better than the 360. Even though the name sounds kind of weird, the One is newer, and if you want to make your son have a great Christmas, you're going to want to buy that Xbox One. And so this is the same thing we have here with minimal APIs. The name sounds limited. And the docs and examples reinforce this. You go look at all the examples and everything is shoved inside a program CS, and it makes it look small and limited, and it creates a bad first impression. And first impressions tend to stick around, even though minimal APIs has been around for several years now in several releases of .NET, and with .NET 10 coming out, this kind of thing saying, hey, it's not great for big projects, it's only great for small, tends to stick around. And I think it's because all of the endpoints are shoved inside a program CS in the samples, and I'm going to show you today how we can get around that. So first off, let's talk about why we should even consider APIs and what's the real story here. Well, first off, they're lightweight and they have an extremely fast startup, which means if you're running this in a cloud, you know that cold starts are a problem. Fast startup for minimal APIs, and they beat Node and any kind of scripting language in performance and raw performance, and most of the other compiled languages too. And they're pattern agnostic, and I think this is why they called it minimal API, is that they're going to have minimal resources that you need to install and only what you need that you install. And it's also, we're not going to tell you how to do it. We're not going to tell you necessarily how to do it. It's going to be pattern agnostic. So no more MVC controllers. We need to figure out the pattern, and it's API first. There's no Razor view engine that has to run at startup, and it can start small, and you can scale out your structure if needed. And it has the full .NET with it, and that's called DI, or dependency injection, validation, OpenAI, and ahead of time transpiler, AOT. And this makes minimal APIs the perfect choice for any new project you're starting in 2025 or 2026 and going forward. And so let's look at a quick comparison between the different broad frameworks here. We have MVC from Microsoft. It's a full web stack. It has scaffolding, but it's heavy for APIs. The startup is slow when you compare it to minimal APIs because it's instantiating things like the view engine. Minimal APIs are lightweight, high performance, pattern agnostic, code it how you want, and you also get the full .NET, but you only bring in the things that you need, and it has less scaffolding by default. So there is some code that we have to write, but the payoff is in performance and lightweight. And then when you look at something like Express.js or other kind of scripting backends, it's simple, it's async first, and it has a huge ecosystem, but it has slower performance. And when performance is something that you have to have, I mean, pretty much minimal APIs is the choice to go to for the enterprise, and there's a reason why. So let's look at a structured project here, and we're going to look at this code here in a second. And I've got several folders here that I like to create when I'm writing these. And now I want you to be sure that you understand this. This is one proposed organization with an extension method. You can group these however you want. So this isn't the way you do it. I'm going to show you how we can get them out of Program CS. So typically I create a folder called endpoints. If I have a filter, I'm going to put those in there, and I have my models and my DTOs in a separate folder, and then I have services. If you want your models to ride along with the endpoints, which a lot of people do with like a Reaper pattern, that's easy enough to do with this. So don't get hung up on how I did it here. Just know that we're moving these out of the Program CS into its own structure, and you can group these however you want. Now, extension methods are the secret sauce, and once you know how to write an extension method to extend your mapping into Program CS, it makes everything else kind of easy. You can group this however you want. So you can group them by feature, domain, or resource, and your Program CS stays clean. And remember, you can group these however you want. And so we can get this to one line of code. You can see here, app.map customer endpoints will map all of the endpoints for our customer entity. This could be a feature, it could be a domain, and I'm going to show you how to write that in just a second here. So let's write some code here, and I've given you in the description below here this actual repo that you're going to use. It'll be complete and finished, and you can explore the rest of this code as you see fit, but let's write some code. All right, so you can see here I have this repo here, and I'm going to go through a couple of these folders, and I'm going to show you how we would implement this. All right. So the first folder that I want to bring your attention to is this endpoints folder. And this is kind of where all of our code will live for in a particular endpoint. And here I've also got them grouped by feature here. In this case, it's by entity called customer, but this could be admin or whatever you want to do. And I've got in here, I'm going to have a file called customer endpoints. And in here, this is my extension method here. And you can see here, this takes on the interface endpoint route builder, which allows us, when we call this, to take in the current routes that it has and append to it. And that's what this passing this parameter as a this method allows this to be called multiple times and chain these together. So we can call any number of endpoint builders and it'll group these in here. And so you can see here, I've got a group here and the group has its own route. And then in here, the different methods that I want to run. And this is a get method for get customers. This is a get by ID. You can see it's passing a parameter to it. And then we also can have a post here. Notice these have the same URL, but they're different actions. Okay, so it works the same way as you would any other language. We have actions, we have methods, and we have routes. And all of these can be grouped together. And when we turn it, it'll map all these in here. Okay, so this is the magic. If you can remember how to build this, you can map any number of endpoints together and call this method whatever you want, and then group the associated endpoints under it. And you can see here, this is my implementation for a method. So if I look at this get customers here, you can see here I'm calling this method inside this group definition here. So this is the actual implementation of it. Could I put the code right here with the group? Absolutely, I could put the code in here and the sample show you doing it that way, but I like calling a method here to keep these separate because I could pull this into its own file, but I wanted to show you a way to make this look more like MVC controllers in case you're doing that. And this is just my endpoint method here, and it's being passed in a service. And one of the things that's also in here for free, a cancellation token, which we use a lot in ASP.NET. And this allows for any kind of long-running process. If someone closes the browser, this handles this pretty nicely by closing up the call. And in here, we're using a service method here. So the service method get customers async is where the entity framework call happens. And I'm using a service method in here. And so my endpoint is just a route into the service. We do that for a number of reasons here at Coder Foundry. A lot of times we're writing full stack apps, and that full stack app has a server-side component. It also has a client-side WebAssembly. The client-side WebAssembly calls this method. The server-side method calls the service directly. And so now I want that code in one spot so I can dependency inject the service into this method here, and then both places call the same code. So let's look at the program CS and how this looks inside. So this program CS here is how any web app starts up here. And you can see here, I'm creating my database. I've got my database coming in here, and this is where my injection happens, all right? And so my interface customer service is injected, and this is the implementation of that service. And now that's injected, and now it's available to anything that participates inside of this app here, right? So it puts it in the DI container. And you can see if I come down here, this is where you see the code that you get from the sample. And this is straight out of the sample. If you're running this in 2026 Insiders Preview, which I have here in Visual Studio, and .NET RC1, this still is the way it's written. And you can see here, I've got the implementation here, the route, and also the code in here. It even also has like this variable here that it uses for the summaries in here. And it also has even an internal record here that calculates the temperature. And so that's kind of bad if you think about it, separation of code. And so let's run this and see kind of how it looks today. Now, one of the things I'm going to show you is also in .NET 10, we have open API support. And this allows us to run different things for our documentation than we have in the past. And one of those is Scalar. And this is Scalar right here. And you can see this is this endpoint. It allows us to make this really beautiful documentation here. And I'm going to test this request. Hit send. You can see it pulls back these records here. So it just kind of works. So I've got an application that is listening for endpoints, and then it serves them up in a web server. All right. So what if I wanted to bring my customer records in here? Well, this customer endpoint, since this is a public static method, I can call this from Program CS. So I'm going to go into Program CS, and I'm going to call app.mapCustomerEndpoints. And so I'm just calling that. And the reason it can see it is I do have this using statement up here that adds these methods in here that it can see, and because it's public, it can see it, and now I can call it. And since it's going to take in route endpoint route builder, this app right here will extend it. It's being automatically pushed into it. So when I run it, now I'm going to get my customer endpoints already mapped. So check it out. Now I have a folder here, and now I can run these. Now this sample comes fully configured with a SQLite database and sample data. So all you have to do is just run this sample, and you're going to get these sample records in here. If it gets regenerated, I'm using something called Bogus, so you may have different records, but it's going to generate 50 records by default. And so you can see here it's serving those up, and I can also get a customer.id, test it out here, and I can pass in the value of say 35 or something like that, and it'll send it, and it'll find an individual record here, Lexi Showalter. Now let's also look at this other sample here, this create new customer, this post. And I'm going to show you something else that we're doing here. So if I fill this out, and when I hit send, it's going to throw an error, and it's going to say an unexpected error has occurred, status 500, and it says, hey, this not implemented exception. I want to show you something really neat inside of what I built here. So let's close this down, and let's look at the customer endpoints right here, and come down here and see I have this private static async method. And you can say I'm throwing a not implemented exception, but you may be asking yourself, well, how did it's through the error, but how did it get to the page? Well, I'm also trapping these as well inside this filter here. And if you look at the group up here, I've got this add endpoint filter exception handling filter that I added to the group, and therefore every endpoint that's in this group will run through this filter. And that's a very powerful feature we have here inside of .NET. And you can see what it's essentially doing is running the method, wrapping it in a try catch. And if it catches an exception, it returns that problem, okay? And you can see here, I'm also checking to see if it's in development or in production. And if it is, if it's in production, it won't show the detail. But if it is, it will show the detailed message. My throw has a message coming out. And you can see here it throws a status 500 and an uninspected error code. That's where this came from, because I'm filtering through all of my endpoints through this exception handler. Now you could do this handling for any exception. You can do it for 500s. You can do it for any other error that you want to think about, and other types of filters as well. I just want to show you kind of how this works. So we could come over here and let's implement this code here, because I think it's real important to show how we write code. And so now I've got my endpoints implemented. So I'm going to create a created customer here, and I'm going to call my service with the customer being passed in, though, as I type it in, and my cancellation token. And then I'm going to return a type results, and I'm going to return it in a certain way here. I'm going to say value, created customer, the route name, and the route values. And what this will do is return a 201, and that's typically when you do a post, you return a 201 to your ID method so that they can see the result inside the database. So now let's run this. And now we have a fully functional created customer. And go to customers here and get customer by or create customer here. And I'm going to show you one other thing that's built into .NET here. You can see here I've got these required elements here: address, city, email, first name, last name. And this is model validation. This is new to .NET 10. So if we go to test this request here, and I don't enter anything, I just try to hit send. Look at this. It gives me model validation before it does anything else. And so model validation is first, and then any kind of error exception filtering happens second. So I need to fill this out for it to actually accept a request. And now when I send this, boom, there you go. Look at that. This is our ID, or our object that was created. Kind of cool, right? And if I go back and close this down and I run get by ID, that new value should be 51, because I knew I started out with 50. And look at that, there it is. And it returns it. Kind of cool. All right. So if we look at this code here, this is all the code that I have. I have it kind of in the GitHub repo. It's public. You can go, the link to the description before if you want to explore it. We looked at the exception handling, we look at the customer endpoint, and we look at the program service here. One other thing that I will mention here, that model validation is happening right here. This is how easy that is to do. This says add validation, and then any model, and you can come here and look at this model here, has these attributes or annotations on top of the model. And this is where these messages are coming from, both in the entity model, and also have a DTO here that I'm using, the same thing. It's got these annotations here, and it reads those and creates messages for an API endpoint. It's a really requested feature for .NET 10, and it's available now. Let's get our key takeaways that we can from this. So it is naming plus the examples gave minimal APIs a bad first impression. That's not true. Structure and the extension methods unlock scalability, allowing you to bring whatever pattern you want. And then the pattern agnostic. You can bring a service pattern, a repository pattern, a Reaper pattern, mediator, whatever you want to do. You can definitely bring that pattern, vertical slice, whatever you structure it however you want. As long as you run an extension method or use group methods, then how you structure code's up to you. It has built-in validation, as we saw, dependency injection, open API. We didn't show this, but also auth is built in as well. And so it's a full-featured API framework ready for any size project. And it's perfect backend for Blazor projects or React or Angular. And minimal does not equal small. Minimal equals flexible. So I hope that helps about minimal APIs. It should be something that you should be looking into if you're not already. And if you are on an MVC project, you absolutely should consider for your next project. Well, I hope this helps. Good luck and keep coding.